Hello everyone. In this video, we are going to solve problem number 1.146 of the book Problems in General Physics by Irodov. Without further ado, let's get right to it. So the question says, a round cone A of mass m equals 3.2 kg and half angle alpha of 10 degree rolls uniformly and without slipping along a round conical surface B. This is the conical surface, so that its apex O remains stationary. The apex O remains stationary. The center of gravity of the cone A is at the same level as the point O and at a distance L equals 17 centimeter from it. So this is the center of gravity of the cone and it's at the same level as the point O, the apex, and the distance is L, which is equal to 17 centimeter. The cone's axis, the axis of the cone, moves with angular velocity omega. This is given. Find A, the static friction. The static friction, this is static friction, force acting on the cone A if omega equals 1 radian per second. If omega equals 1 radian per second, we need to find the static friction force. B. At what values of omega of the cone A will roll without sliding? At what values of omega the cone A will roll without sliding if the coefficient of friction between the surfaces is equal to K equal to 0.25. In B, K is given 0.25. We need to find the coefficient, we need to find the value of alpha, value of omega, for which the coefficient of friction between the surface is equal to K equal 0.25. Keeping in mind that cone A will roll without sliding. Rolling without sliding, this is the condition. Sorry, this is the condition. Static friction, rolling friction. Static friction less than or equal to Kn. This is the condition. So let's start solving. A. So first of all, let us equate the equations of, this is the free body diagram where normal, this is the normal, this is the normal, this is the weight, this is the center of gravity of the cone, and this is the static friction. So equating along y-axis, all the components along y-axis, we get n cos alpha, n cos alpha minus mg, this is mg, plus static friction along the vertical axis sine alpha. This is alpha, the angle which equals to 0. And equating along the horizontal axis, that is x, we get fr cos alpha, fr cos alpha, this is the cos alpha, fr cos alpha, minus n sine alpha, n sine alpha, n sine alpha along this line, minus n sine alpha equals mv square by r, where r is equal to L. So m, instead of this we can write omega L square by L, that is n omega square L. So we get this equation, our first equation and our second equation. Let's rub the equations now to move forward. So we get our two equations. Let's write it out here. Our two equations were n cos alpha minus mg plus fr sin alpha equals to 0, and the second fr cos alpha minus n sin alpha equals n omega square L. So these are two equations. Now equating these two equations, we get fr cos alpha minus sin alpha by cos alpha minus fr, the static friction, along the vertical axis fr sin alpha plus mg equals to n omega square L. So Fr equals the static friction mg sin alpha plus omega square L by g cos alpha. On substituting the values given in the question, we get static friction equals to 6 Newton. So question number A, part A is done. Let's move on to part 2, part B. The final answer we get of A is static friction equals to mg sin alpha plus omega square L by g cos alpha. Now moving on to part B. For rolling without sliding, the condition is static friction less than or equal to Kn, K times the normal force. but along this axis, the normal axis, and equating along the normal axis, we get n equals mg cos alpha along this line, the normal line, mg cos alpha minus m omega square L sin alpha and omega square L sin alpha along this is omega square L along this line parallel to n on this line. I mean on this line mg cos alpha along this minus m omega square L sin alpha this. Now putting it in the condition, in this condition, from here we get the static friction. The value of static friction is less than equal to Kn, then mg sin alpha plus omega square L by g cos alpha less than equal to k times mg cos alpha minus m omega square L sin alpha. Rearranging, we get omega m omega square L cos alpha plus k sin alpha less than equal to k mg cos alpha minus mg sin alpha, which gives us omega less than equal to root over g k minus tan alpha divided by 1 plus k tan alpha inside the square root times L, which gives us 2 radian per second after substituting the values. Thank you for watching the video. If you liked the video, please don't forget to subscribe, share, like, and also comment in the comment section below. Thank you.